In this course, we are actually learning how to export assets, like static assets, dynamic assets which you can place in-game, vegetation, things you can create in your 3D app, and later on do things like create breakable assets in the engine. It also includes like creating textures, exporting 3D meshes, and all the things you need for working in the engine. First off, we start actually with our engine itself. We have a little test scene with grass prepared. In this case, it uses like a grass texture. This is the texture which you can find in Assets, Objects, Natural Grass folder. If you open it with Photoshop, you can open the grass PSD, or you can just open the TIFF file in this case. This is just the source file. You can see the file. And this, for example, is like a standard diffuse texture like you would create in Photoshop. And you can save them for our engine just by calling it like you would like, for example, grass, or like another version like grass test. And there you should have like a cryTIFF plugin TIFF. It's our Cryengine file format. And you can export it like this way to say our engine, okay, here, this is a file which should be compiled into engine format. And then you should actually get the resource compiler plugin which boots up and lets you pick your texture formats and things. And in this case, we just export an albedo map with alpha. So you can save it as cryTIFF, should get the dialog. You can change resolutions here. You can change the MIP formats for the MIP maps. But in our case, we just press OK. And now we should have another texture in here. I just named it grass test diffuse, and this is like another diffuse map. The resource compiler automatically like detects it. It creates a cryasset file here. And now you have another texture. For test case, you can just paint something in here. Press save, and it should also, like when you control save, like it should automatically open this dialog and save it again. And when you then go into the engine, you have our grass asset, and you can open the material browser, and you find it here in Tools, Material Editor. And this is basically the same directory as in our Explorer in Windows. So you have it here in Objects Natural Grass, you see, and you find the material of the asset also in Objects Natural Grass, and there's the Grass 1 asset. And now you are actually able to pick a texture here. You see, like this is the material IDs, this is the grass material, and it has 3 material IDs, and you can pick the texture here. And if you open it with the little folder, you can see like the grass diffuse and the grass test diffuse. And this is our newly created texture. You can pick it, and now it's already applied. You can close the material editor again, or just minimize it how you want it. And you should actually be able to see the test texture here, where we painted this little black spot in there. So it's actually quite easy. You can do quick changes in our engine. You can just modify things quickly. Now you have the material modified, and press save, like Control S. Really quickly, you can just keep these settings, press OK, swap back to the engine, and you should immediately actually see the changes. Now you have the red colors in here. So you don't have to reconstruct this entire thing with the material again. It's just quick workflow. Textures is in there. You press Control S, and it's done basically. So yeah, this actually concludes the Photoshop plugin. We also have. This is just a standard diffuse texture. We also have more complicated textures in most cases for objects. Sometimes you have like normal maps and all these things. You can find a test object in our project as well. It's like in Objects, Natural Rocks. We have like a little rock prepared. And if you open it, like the rocks PSD, you see a little scene. And if you are familiar with Photoshop, you know, you can have a few layers. You can go into the layer dialog, and there you have like different textures. It's like an albedo map, which is similar to a diffuse map, a normal map, and a gloss map. And in our engine, you're able to actually use all these different kind of textures. We have quite complicated shaders, and if you swap back to the engine, you have this rock. This is actually the rock using all these different texture. And you can export like normal maps and gloss maps as well. The normal maps They are very oftenly combined with gloss maps. You can keep the normal map in the RGB channel and the gloss information in the alpha channel. And now you have like a combined texture when you save it. And pick the Creative plugin, you see this little rock DNNA. This is like a combined normal map and gloss map texture. It will automatically pick the normals with smoothness preset for you. This actually says the engine like it's a normal map with gloss in the alpha channel. And you can save it like we did before. And it will create like a new texture. In our engine, you can also debug them. And you can actually see them if you go into the top tools and enable the view modes. And there you get another bar opened. And you can toggle between the different view modes. There you can see your albedo maps, which you have exported in Photoshop. Here you can see the specular maps. This is not including a specular map, it has just a value. You can show the gloss maps. This is like the texture you can see in your file here. And you can see the normal maps here. This is the normal buffer of the engine, so it creates actually more details than the actual geometry has. And you can swap it back, and this is the standard rendering. Yeah, this actually concludes the export process. It's quite easy. You can do really quick changes just by adding some details, pressing Ctrl+S quickly, and the Creative plugin picks up the necessary details and exports it in a second. We also support translucency textures, height maps for displacement mapping, different kind of textures like masking, detail maps and things. We don't have any test objects in this particular case. You have the folder opened, like these rocks. Just go one back, there's natural, and there's the trees folder. And you actually should see a tree leaves opaque texture. It stands for opacity. We just called it like this, and you can actually just open it with Photoshop. This is how it looks like. It actually just says, okay, the white areas where light is supposed to shine through, and black where the light is supposed to get blocked. And you have the branches of this tree. And if you see it in the editor, you have the little branches which are actually black because it's denser material. And you have the leaves which are like really thin. They are just having this property that they actually can shine through. But yeah, you just prepare like in masking, white is bright and black is dark, and it actually picks it up automatically. You can also just test it. If you paint something in here, something black, press save, and then you should have the black lines in the tree not shining light through there. It's a straightforward workflow, so yeah, you can actually see this or debug the view here as well in this little button. And now we should have like a little spot in the leaves where you have this black line. Yeah, it's somewhere. You can actually also export textures straight from Substance Designer when you work quite oftenly with it. You just save it as TIFF, and in the engine you can actually, it's a bit different. You can go into the asset browser and right-click, press import, then pick your texture. In this case we don't have like, you could go to this folder now, and as soon as you open the texture, the same dialog resource compiler will open, and you can press OK and get your texture as well. Straightforward workflow actually. The trees, for example, if you open the editor, they use some sort of translucency map for leaves, so you have light shining through. All this you can just create in Photoshop and export it actually with the Creative tool. There is also like a cryasset file generated at the same time, and this will actually say the engine, okay, generate me a DDS file for it, but it's not visible for the user in the end. There is a file like which is used for the graphics card later, but yeah, you don't have to focus on it. You just save your TIFF file, and it's quite common file format, and the engine does the rest for you. So yeah, secondly, to create an engine, actually you need your 3D assets. And what we quite oftenly do in our production is to use 3ds Max. This rock has created the 3ds Max. And when you install your Cry tools, you should also like get the 3ds Max exporter with it. So yeah, if you have this installed, you should actually have Cry exporter with for 3ds Max. You can actually just test it quickly by going into objects, natural rocks, and there we have a rocks max file in there. This is the exact max file for the rock, which you can see here. We just double click it and 3ds Max should actually open for you. Just press OK. Yeah, and this is actually you can see it, it's the rock we have here. So the Cryengine exporter, you can actually find it in the command panel in 3ds Max. So you press on this utility, and if you don't have it in here yet, then you click on this configure button, and there should be a dialog for you. It looks like this. And if you scroll down, you should have it in here. Cry tools, Cryengine exporter, and this is the same list as this one, and then you just drag it over here, and it should appear then there. And then you just press OK, and you have it there. So if you have this, you can actually see our exporter tool. This is actually everything we work with all day. It's a really quick and fast exporter. And these are, for example, 2 rocks. We have this in the engine now, and we don't have this in the engine now. This is just in the max file. This is like rock 01, and this is rock 02. And you can see they have some LODs applied to it. You unhide everything, you should get the LODs and the proxies. You can quickly export stuff with the editor. Here you have a list like of geometry objects which you can export. You can select the root of the object, like for example rock 02, add it to the export list. This is the geometry list, and have the export file per node enabled. Merge our nodes, we don't need this because it would just merge different nodes. And you can then click export, and it's already exported. It actually exports the file like in the same directory as the 3ds Max file. So now that we have our rock in the objects natural rocks folder, you will actually see like a rock 02 CGF in here and a cryasset file. The cryasset file is used for the editor so that it can actually interpret the geometry and find it quicker with the asset browser. But it's generated at the same time. If you have this, you actually have your first objects exported. So if you go back to the engine, you can actually then just place it by create object, click on brushes, and then you can place a brush object. If you go to the same directory in natural rocks, here you have the rock 01, and here you have the rock 02 asset. And you can just drag it over, and this is now the rock we have like in 3ds Max, just in our engine. It's straightforward. You can just, like in Photoshop, you can change things quickly. You go in 3ds Max, you can go into the mesh, press 1, change a little vertex, go back into the exporter, press export again, and you immediately see the changes like in the editor. There you have it, it's like already modified. So you don't have to press many things, you just press once export and it quickly updates in the editor. Usually for static assets, you need LODs, especially for a game engine and for like real-time rendering, you need like different kind of detail, otherwise the performance is not good enough. So in our case, we do all these things in 3ds Max. We have our main root, this is our LOD 0 with the highest detail. You can actually select this one. Yeah, you can see this. This is like the LOD 0, the rock. This is the root. And the LODs are actually linked to it. For LOD 1 we call it $sign LOD 1. For LOD 2 we call it $sign LOD 2, $sign LOD 3, $sign LOD 4. And physics proxies usually are called like $sign physics _ proxies. We have it also in the notes in case this is complicated to remember. And you can put any number behind it. You can do the same like for easier memorizing behind the LODs as well. They just need to be called $lot 1, 2, 3, 4, 5, or how many lots you need. And you just link them to the main root. Here you can see it. And this should indicate for the engine, okay, these are lots for this object, and it will automatically be applied later on when you press the export button. You can actually see them here as well. If you go close and further away, you see very slightly popping. Alt-W enables the wireframe, and there you can actually see it more closely. And you can maybe see the, yeah, you can see it change very slightly. These are the lots which you actually have. And these are basically always within 3ds Max so that you can quickly export it, quickly iterate it, just pressing one button, and these lots will be adjusted as well. You have to name them here. Like the main root of your object is actually the name of the object later in game. If you, for example, like call this rock2 main root here, rock2 test, press enter and export the rock02 test, it will be now a rock02 test CGF. So you can actually have like one max file with a big collection of objects. Sometimes you have like a house with concluding even hundreds of objects, and you can even like export like multiple objects at once as long as you have them here in the exporter list, and it will actually export now both these objects at the same time. So you can just keep a export list and press the button once, and it will export all these objects at once, and you will see them immediately in the engine afterwards after pressing the single button. The pivots just have to match, so it takes always the local position. Even if you set off these lots here now, it should also like move these lots relatively to the pivot back on this position. So it's not really important. If you like it like this, some artists work this way and they have the lots right next to the object. You can also work this way. So it's not just one big chunk of objects intersecting each other. And it will also export the file and relinks or removes the objects related to the pivot onto this one. In our engine, actually, we have different ways to use static objects. This is now a static object. You can't deform it, you can't break it or anything. It's just one static thing. What is important for it, you need a proxy. You can actually see it in here in the max file. This is just needed for physical interactions, so when you shoot it, that actually your bullet gets blocked by it, and that the physics engine notices, okay, here this is an object where it's supposed to like calculate some physics. This is what you need for it. You always call them like $physics proxy. If you have this, you can like walk with the character and get also blocked by the proxy. So it has some physics properties to it, but is still static. You can actually see the proxies in the engine as well. You can go to the console, it should be right on the bottom right, and you can type in there p_draw_helpers space and press 1. And then you see actually proxies in our engine. You have it here as well. So this is the same proxy which you can see here in the 3ds Max. If this is not showing up in the engine, something is wrong. Probably you don't have, or you have something linked wrongly, or you have it like not named correctly or something. If this doesn't show up, you can actually walk through and something is wrong in the engine. This actually concludes the static mesh export. If you actually export a mesh from 3ds Max, you also need to like have some material properties applied to it. In 3ds Max, it works actually with the material browser. If you press M, you should get like the material browser, and you have to switch it back to the compact material one. And there you have the material, which is like used for the rock. Our rock in this case is just using one material ID and a second material ID. The first one is for the render mesh itself. It's also the same one like for the LODs. And a second material, which is the proxy. Render materials are always like exported the way that you go in here in the first ID, and you need to apply a Crytex shader to it and disable the physicalization and have it set to default. This says the engine, okay, it's supposed to be using a render material and not a proxy. And it will actually use it for this where you all have the material applied. You can actually see it here. This material is applied to them. And you just have to apply it, and it will use this material. The material is called rocks. So it will actually use this material here. You can see it in your folder. It's called rocksmtl. And there's all the information stored which you create your material with in the engine, your texture files and things like this. And you just say it here, okay, it's supposed to use rock material with this render material and this proxy material. For proxies, in this case, it's material ID 2. We have it set to physicalize and set to physical proxy. So this will say, okay, this is supposed to be a proxy for the engine, and it will export this as proxy and this one as render mesh. And if you have this, it shows up here in the engine. And you can go to the asset browser, to objects, natural rocks. And here you see the rocks thing. This is a material file. And you can actually open it in your material browser, or you can just double click it. And this is the same like in 3ds Max here. You have this one material ID, it's the rendering. And the second material ID, this is the proxy. The first material ID is just set to illum. This is like a shader we use for objects like rocks, houses, and static materials. You can set your surface type here, what physical properties it's supposed to have. And you can also add your textures here. This is the rock texture, and this is the null map texture of the rock. They are actually in here in the rocks folder. You can also see them here. And you can modify them here. If you want to add specular textures, detailed textures, or height maps for displacement mapping, you can do this here as well. And for the render geometry, you have all these properties. And for the physics proxy, we don't need them. That's why we have it set to no draw here in this case. And the surface type as well to concrete, because concrete is quite close to rock. So it will actually take these properties and assign them to the object itself. So later on, if you have a game character in here, and you shoot at this rock, or you make it physicalized, it will actually pick up this concrete surface type, and it will react accordingly. So when you have this concrete thing, it will actually spawn a particle effect like dust and spit up some rocks and things like this. For example, if you would pick wood as surface type, it would spawn some wood particles there. It would also be significantly lighter, as rock or concrete is a heavier material. Yeah, this will actually define weights and particles and things. Also, like when you walk on an object, it will actually create a sound, and in this case you would want some sort of stone sound or concrete sound when you walk on it. So this is related to that. And here you have all properties, you have shader features. You can enable detail mapping, decals, parallax occlusion mapping, tessellation, all you need for your objects. And we have the illum shader, in this case for the rocks. This is our big, almost everything shader, so it can do most shading types. We have different ones for vegetation. We have water shaders for the oceans and water. It's mainly used in the editor. We have particle stuff, but for static objects we keep mostly like illum or vegetation. So we actually spawned it already as brush. Like these are brushes. These are just static objects, they don't move. If you jump in game, they are actually just not moving, or just you can place them like this. You can create them here in the brush menu. And there's like a second type of object which you can spawn as well. It's, for example, you can go into tools, you can go into vegetation editor, and you can add this rock here in here as well. You can just add a group and then add the object and go into rocks. And here we have our different rocks. And you can spawn the same rock as well as, you can spawn the same rock, for example, as a vegetation file. And this is actually quite helpful because you can populate levels very quickly. You can procedurally scatter them on a large surface. And we do it quite oftenly if we don't want to place everything by hand. It's good when you have like a imported height map and want to use some objects on a large scale map. You can actually put them in here and you can change sizes, variations, rotations. In this case, we can tick this on and we can actually define properties for this vegetation object. You can like define angles and things like this. And you can just go in here and change density to 10 and spawn it like on this entire map. For example, if you press on here and you have this rock scattered all over the place. This is now also a static object, it's just vegetation. But it's quite useful if you have like a big height map and you want to scatter an entire world quickly without placing everything by hand. You can do this quite easily. You can also use it in combination with the terrain editor. It's in here and you can paint something, for example grass. We have it like this. And these small grass objects, they get scattered automatically on here. So you don't have to do this by hand, they just get placed. In most engines you have to do it by hand, which is quite annoying. You just have to import the informations or paint them by hand and you can just let it scatter. You can also like let scatter this rock on this grass field if you just, instead of pick this gray material, press the grass here. And now these rocks are just scattered on this grass, which is quite useful. You just paint this one thing and you have the rocks with the grass painted there, which is quite nice. And yeah, another type of object which we actually can use as well as like entities. And these rocks can be used as entities as well. You can actually go in here into empty entities and place one of these here. And when you go into the property of the entity, you can add a component, which is like our geometry, a mesh geometry, and further down in the mesh geometry, we can actually pick our rock again. It's here in File. So we go into Objects, Natural Rocks, pick the rock, and there we have our rock. And then you can add another component, for example, Physics, Rigid Body, and now we have this object physicalized. So the rigid body actually says, okay, physicalize me this mesh geometry piece. And you can type in masses or density setups. And you can also already like press play here. And it should fall down and now it has some physical properties. And you can play around with it and can use it as a rock entity. It's all the same for this export workflow. So you can do all this just by the static object and you can physicalize it, you can use it as brush, you can use it as vegetation, or you can use it as entity in several arrays.
What we also use during production a lot is static brushes is easy. We just export it, we place it in the world, it stays there, it never moves. As soon as we have entities like whatever is moving and we want to give masses to it, and we place barrel, for example, 100 times in the level, we start to create archetype entity lists. But this is basically a list where you put your object in, give it a mass, and then you grab your object from this list and place it in the world. And whenever you change the properties in the list, it will propagate the changed properties to all the objects in the world. So you don't have to set up every single object by itself, but you can start putting your objects in archetype lists and then using it from there to have this properties instanced to the objects in the world.
Exactly, yeah.
There's another little one which is called Prefabs, which is very similar. It just enables you to have multiple objects in one container. You can make a little arrangement, put this prefab multiple times in the level, and if you change the master prefab later, this will also propagate to the prefabs in the level.
Yeah, for the asset workflow, it's actually quite easy. It's the same for all objects which are not supposed to deform or are supposed to do anything else than just being like one object, and it's the same for all of them. Yeah, you can play around here. Press play and move them around and it should work. Another type of object actually is vegetation. You can actually already see it in our test scene. If you have it open, like this, for example, is moving a bit. And it's using some sort of different shader and as well like a different setup for 3ds Max. This is some different objects. It's also like placed as vegetation. You can see it also when you paint it with the grass thingy here. And you can actually take a look at them if you go to natural grass and grass max. This is the 3ds Max file for the grass. You can create this movement, which is actually affected by wind in our game. You can change the wind in our engine by going into Tools and the Environment Editor. You can actually increase the wind and everything will be affected more by wind, and decrease it and do things with it. And you have to somehow say the engine, okay, this is supposed to like move there and this is supposed to not to move. So we do this by using vertex colors. If you open up the grass max, you have these files in here and you can actually click on them and press the right mouse button and tick this checkbox here, vertex channel display. And this will actually show you all the vertex colors of the objects. You can press F4 to remove the wireframe. And here you see what we did. Actually, we have different color channels, like the green channel, which is affecting the face, the blue channel in the object, which is affecting the strength, and the red channel in the vertex color, which is also affecting the strength of the little bending. And it will actually say how strong it's supposed to move in the engine. You can actually go in your GrassMax file and even go in here, add a vertex paint modifier and paint some blue colors in here. Change the size a bit, like this. And if you now just export the asset like we did before with the rock, you can select it, go into the exporter and put it in the list and press export. It should now move the object differently. You see, it's like wobbling around in this place more strongly than before. And it will say the shader, okay, here this is supposed to affect wind more strongly than this one, so it will pick this up. And you can actually tweak these values as well. If you go into the asset browser again and to the material of the grass object, which is in objects natural grass 01. And you have here the first material ID, and if you scroll down, you should have all these shader parameters here. It's using the vegetation shader. The vegetation shader is a different kind, not the same as Illum shader. You can actually drag the window down here somewhere. Now we have the shader open at the same time, and further below you have the settings for your shader, for your vegetation shader, for this grass object, and you can see bending branch XY amplitude and bending branch XY frequency. If you increase these, you actually increase the bending of the object itself. So you can fiddle around with these and play around, create some strange effects. And the trees, for instance, if you press or if you go to this tree here, you can see it's moving as well. It's using the same feature. You can apply color gradients to it, and the tree will slightly move in the wind later if you apply the colors to it. We use actually these 3 different colors in 3ds Max, and you can do a lot with it.
Can you please show the mesh with the color channels isolated, because I think that's quite interesting how we apply 3 different colors. So every color has a different effect on the vertex shader, and we normally put a vertex paint modifier and we stack 3 of them and make them adaptive, so we can, like in Photoshop, we can blend them as layers. So one vertex paint modifier is holding the red information, one blue and one green, and every color has a different presence in the shader.
Yeah, you can actually see it by
you can just use the saturation adjustment color modifier. No.
Subtract. This is the red channel. You can see it's just in the top of the grass. So it's supposed to bend here, and at the bottom it's black. So there's no bending there. It will actually move here more than there for the detail bending, for the small, tiny movement. And for the large movement, we use the blue channel, so you can extract it by... Okay. This is the blue channel. It looks similar to the red channel in this case. So it will bend more at the top and less at the bottom. This will actually represent the this value. If you change the blue channel, which we've modified just a second ago, here you see it. And the green channel is some sort of phase. So you can actually modify the movement based on time. So shift it slightly and create waves. If you would just put in the blue channel, it would move all the same at the same speed, and you wouldn't create this wavy effect. So you put a slight gradient in the green channel and you get this shift in time, which creates this wavy effect. Yeah, you have less green at the top, but more green at the bottom, so it will actually slightly shift it towards time. If I just make it green, it will actually like bend all the same at the same speed.
It is very complex, but what we sometimes do, if it has to be a bit faster, we even just use black and white. So we make black at the bottom and white at the top. Then you don't have all the details bending, but it will still hold on the bottom, but move on the top areas.
You can create more complex objects with it, even like trees which bend really complicated, like single bending branches and things like this. So you have actually quite a lot of freedom with it. You can even fake cloth objects, like you could having some cloth sheets and let them like move at the bottom, like so that it actually looks like physicalized cloth and things like this. It's quite versatile here, the effect itself. In the grass, additionally to the wind bending, we also have like a little effect which is similar to this one, but it's affected by physics. So if you just go here where the rock and the grass is, you can actually press play. And you can move the rock around, and it will actually affect the grass physically. And this is actually done by bones. So we actually have some physical representations in there which says, okay, here it's supposed to affect the grass somehow. You can actually make it visible with the same command which we've used before for the proxies. Just type in pdraw help us or use the button here at the top, this one. And if you move around the rock, you can actually see these little proxies there. This is the touch bending which we have for vegetation objects, and you can actually use it to physically simulate these tiny plant objects. This effect actually will happen at the same time like the bending, so you have these two at the same time. And it's quite differently in 3ds Max to set it up. Here you have the grass setup, which is like in our rock before. It's like the grass main node, it's the LOD 0 and the LOD 1 and 2. And the branch helpers here, which are linked to the objects, are actually representing the bones, which you can see in the engine, which are affecting them. To make it work, actually, you have to just place these helpers at the branches of your object. You can actually isolate one of these by hiding the rest of the grass. You can select the elements and hide the selection. And then you just have one of these grass pieces here. And here you see I just placed some helpers at the bottom, at the middle, and at the top of the object. And these are actually the same as you saw in the engine. And they are just called like branch 1.1, branch 1.2, and branch 1.3. And they actually generate the bones in here for this one branch. So if they are called like all with the number 1, the engine will automatically notice, okay, they are belonging together, and generate from the bottom up like these bone structures, and put them all at this place where the UV instances are shared. So this actually has a UV mapping. You can open it with the UVW modifier, unwrap UVW, and edit. And here you can see it's this piece. And it's used in this grass piece like, I don't know, maybe 15 times, I think. And the engine will actually pick up the UV space of this, where you actually place the helpers in the mesh. And it will use the UV information to actually propagate these bones all at the same position where you have this UV map. So you just have to place it once in this case, like branch 1, 2, 3, and link it to the main root, to this render mesh. And it will automatically propagate these 15 bones to the rest of these sub-elements which you have in here. Like, if you unhide it again, you can see you have more than just this one here. You have also a second one, and a third one, and a fourth one. And these will get the same bones. It's actually quite nice because you just have to place it once and don't have to skin your geometry like many engines have to do it. So you would have to explode your mesh, put the bones there, skin it, put it together again, and export it. You just put these helpers as representation for bones there, link it, and the engine will detect it and scatter these bones all there where you have your UV space. So you jump back to our engine, and yeah, we ended up with the touch bending. If you take a closer look actually and enable the pdraw helpers mode here and press play, you can see these bones in here, and for one grass object it's like 15 of these bones. So you can actually have some quite complicated bendable objects. You can actually move the stone by pressing on this button here and move it around a bit, and you can actually see how it affects it. And this is quite unique in our engine, that we can create such a complicated bone setup for vegetation, which would be like too complicated to create if you do it with skinning or anything else. It would be just horrible to set up, basically, if you would do it with character skinning and things. You can also affect these here and move them around. And yeah, this is actually all done by this little setup here in 3ds Max. You can actually take a look, you can just hide it and look where the helpers are placed, and they always just need to be like placed right on the vertices of the mesh. So it will pick up the position of the vertice and compare it with the helper, and then the engine does everything automatically if you just have it linked correctly. So for the grass, for example, we have these little branch helpers linked to the root nodes, and the LODs are as well, like for the stones, also linked to the root nodes. So it actually knows that these helpers belong to this, and it will actually then create it for them for the grass 01. That's for the bendable grass. It's actually quite useful in lots of cases. You could also use it for underwater plants. You could use it for whatever needs to be like moving around like this and needs to be physicalized affected or something. Yeah.
There's one more thing which might be very useful if you have to get assets back from the engine. You might have Cryengine assets already, but you don't have source files. You can always click on geometry. You can select geometry.
You go to this rock here. You can actually select it, And in case you don't have a max file or something, sometimes it happens during production that something disappears, whatever, a max file is not there anymore, or you have to or you created like a big road and you have to get this road shape into 3ds Max somehow. You can actually select them here, like multiple objects even, and go to level, save selected objects, you can save groups. And in export selected objects, you can export it as OBJ file. So you can actually have these two rocks here saved. And if you're in a Max, you can actually just import it as OBJ file. There's the rock 01, rock 02. And there you have them. It's like the proxy is not included there.
Then we'll just take the LOD0 base mesh.
Yeah, it takes the LOD0. Yeah. But essentially, you can do it if you have in production a big level and you have to get some positions of houses and roads and things like this, and you have to rearrange them in 3ds Max. You can just do it with a quick export to actually get the connection between 3ds Max and the editor back again. Basically, this setup is always the same. You always have these constructions for most of the objects here. You have a main node, which is the object later, in this case grass 01. You have the LODs linked to them, and you have the branches linked to them. And it's a quite straightforward setup because you can quickly export stuff. You can export these two grass pieces at once and do it like this with vertex colors, and everything should be exported. The trees and things, everything is made the same way. So you can also take a look at the tree file. We have it here, trees, tree max, and it should look the same. It's always just the main root for tree 1 and then the lot 1, lot 2, lot 3, depending how much it has, and linked up to the main root. What we can do actually, we can create an entire new object. Let's just go into objects and create I think it's quite helpful to just get an overview how to create a material, how to create the object, and how to create all the links so that you have something from scratch. So I just go into objects and create a folder called new object. Go into it, so nothing is there yet. And we just make a new 3ds Max scene. Don't need anything. What we need to do first is we have to save the 3ds Max file actually, where you have the asset basically. We can actually just create a box, for instance. We just imagine whatever, that it's some sort of house. If you have used 3ds Max, you know you actually have to convert it to an editable poly, otherwise you can't really work with it. You can add some connections. In your case, you can use a teapot or whatever, and I just call it new object. And what we have to do here, this is the standard materials for 3ds Max. We actually have to create a multi-sub-material, because our engine always works with material IDs, so that you can use different textures and different shaders on different IDs. In this case, we just have a house, so I just make it one material ID. You can see it here, one material ID. This has now material ID 1, so it uses this one when you apply it. In the material for the material ID 1, you have to select Crytex shader and set it to default. If you have set this up, you can go back once in the material, and here you should have some weird name. Sometimes it's default something. In my case, it's submaterial 1. You can actually call this new object, press enter, and now your material later on will be called new object. So you apply this to your objects by pressing this button, and if this is set to Cry shader and default, it should actually do the job already for our engine to tell, okay, this is supposed to use a material and It's supposed to be called new object. You should be able to actually export it already by just clicking on the object, add it to the geometry exporter, and exporting it. Now you have the object in your new objects folder. If you go to create object and brush, you should see your object in your own folder there. And you can now already drag and drop it into the scene and have it. Yeah, right now actually you see that it's like having this red replace me material. This is because there's no material in the editor defined yet, so it's just using this link and trying to find this new object material, which is not here in my folder yet. So it just generates this replace me material. We can go into our engine and we can go into the material editor. You find it in Tools, Material Editor. And now we create a new material by pressing the right mouse button, New Asset, and New Material. You have to take a look into your 3ds Max scene, how you call it. For me, it's New Object. If you call it teapot or house or something, you have to call it this way. So I call it New Object. And if I have this, I can click on here and set convert to multi-material. And now it has created a multi-material for me. And now we can actually add textures to it. We can go in here in the material ID 1 and go into the diffuse slot and select some material. Here we don't have much. We can actually take the rock material or go into engine assets and textures. You will find something. Yeah, textures default. There's like gray textures. I just picked this gray texture for my case. And now this appears gray up here. And you can actually apply the material by just dragging it onto your object, and it should be done actually. Just go next to it and press Ctrl G, and then you can actually walk around. And you notice that you actually will walk inside. So there's no collision yet. You just have now one render mesh, and there's no interaction yet in the engine with it. What we have to do now is create this collision for the object. So you actually have to go back to 3ds Max and create a collision mesh for it. So for my house, I will just create a box in this case, just for demonstration. And drag it here. And give this box the same material as I use for the house. And you can convert it to an editable poly mesh so that you can modify it. And then I select with this button here on the right, I select all my polygons and give it ID 2 in this case. So this means actually my house is using, when I selected the polygons here in my house, it's using ID 1. And when I select the box, it's using ID 2. So I can ensure that this will actually have the ID 2 here in my material list assigned. So I can go now into the second slot here, add a standard material, set this to Crytek shader, and this time I don't use default, I use physical proxy and set the physical proxy to physicalize. So this actually means that this is not a render mesh, this is a collision proxy, and the engine will only use this for physics calculations in the game, and it won't be used for anything else. So now you have actually two of them in here. You have the first one, which is not physicalized, and it's set to Crytek shader. And the second one, which is set to Crytek shader, but physicalized. You can also change the color. I do it quite oftenly because then it's more visible to you that it's something different in your scene, and you can just easier visualize, okay, this is red, this is a collision object. You don't have to rename anything, you just still have your material with the same name here. Just add this one material in here. Then you just apply it to both your object with the third button here, or by drag and dropping it on the object. And this is almost it. Now you just have to select this collision proxy and call it $physics_proxy. And if you have it called like this, the only thing you have to do is going to the top here, and there you have select and link, and you click this button like linking, and you link this proxy, this collision mesh, to your house or to your teapot or whatever you have. And now you see that it's linked to your object file. And this means this proxy belongs to this object. So if this is done, if you've called it this way, and if you have applied your material to the objects, and if you set the material ID of your proxy to 2, you can now select the root object, which is in our case the new object or house, not the physics proxy, and add it to your exporter list again. In my case, it's already in here, and you can again just press export. So now it exported the mesh, and it should be in the editor with proxy already. If I quickly just delete it and undo it, it should update the mesh, and you can now press this draw helper button, and you see you have this physics proxy in here.
It's a bit complicated to have a separate mesh. It depends a bit on what you do in your project. So we mostly do separate physics meshes if we have a lot of stuff on the physics engine. So for shooters you have raycasts, you have AIs that want to look through walls, you have multiple people that shoot over long distance. So the physics engine is very busy with shooting raycasts and with checking. We have another project, this Climb VR project, where we have nearly none physics going on. So the physics engine is super chilled and has nothing to do. So there we just take the render geometry, and if you go to ID1, and you could also say physicalize the render geometry. If you make this physicalized on, then all your render geometry will be exported physicalized. If you have no physics going on in your project and just walking, then it's easy. You can also do this. But as soon as you have a bit more physics interaction and raycasts and collision stuff going on, it's always good to have a second physics geometry, which is way more simple. And also what happens now is you see this proxy, there's proxy with lines on it, and there's proxy with no lines on it. Right? This proxy that is exported as box now is recognized by the engine, by the exporter, as a simple box. It checks and says, oh, it's such a simple box, I will not even put physicalized triangles. I will just have a starting point and 2 dimensions or 3 dimensions, so 3 values, which build a box. Normally for how many triangles? 12 triangles, I need way more data to build 12 triangles. So if it's simple primitives like sphere, cylinder, box, the engine recognizes them automatically and displays them as a primitive proxy. So you see there's no lines drawn on it, so it means it's the cheapest proxy you can ever get. Right? The render geometry Ronny just added and re-exported has the lines on it, so that's way more heavy physics geometry.
Yeah, it takes a mathematically correct box, which is cheaper than having like multiple polygons and calculating for the polygons like a collision. So this is actually quite cheap proxy I have here. And if you export this file, if you jump into the game with Control G again, you should have some collision now. So you can't walk in.
See it around the player. The player has primitive capsules, so it's very easy for the physics engine to work with this stuff.
And this should actually be useful for all your projects you do. So you can actually now physicalize the objects, you can shoot against it, and it is solid. So this is actually the most important thing to have interactable objects with. Yeah. There's actually more complicated objects. This is now all solid physicalized objects. You can also take this now, and it uses the proxy, for example. If you want to use this object as a physicalized thing, you can just go to the rock, which we've done before, and you can even edit here. And this will be also now physicalized if you just drop it. Oh, it has a too low mass apparently. Yeah, and it will drop as well. Like this, as soon as you have a proxy, it's automatically like, it has weights, it has volume, so this works. But there's actually more. There's actually objects which are not just physicalized, but you can also like break them. So you can move them and throw them down and they will actually break. And this is a bit more complicated to actually set up. So you have multiple pieces and you can link them together and use them in this way. I can quickly explain this. It's similar to here, like you have your physics proxies, but one of these objects actually conclude more than just one node. You can go to assets, objects, natural, rocks, and there you have the rocks breakable max. You can just double click it and open it. And as soon as this rocks breakable max is open, you see this is not just a single rock, but it's like multiple small pieces, parts of the rock. So you have to pre-cut it and link it together with little helpers to actually hold it in place. You can open it in the lister of 3ds Max and you can actually see like this is the main object and these are the parts of the object, the render parts. And you can actually press unhide all and it will show the rest of the stuff. And now you will see like there's joins which are linked to the main object and closely in between two parts so that you actually can link these two pieces together. And how this works actually is that you can apply some settings to these helpers and apply them some pull limits and some shift limits. For instance, that when the rock actually falls onto the ground, there is like an impulse spawned which says, okay, now this impact happened and it has a certain number, and if this number not exceeds the actual limits which you have here in your dummy, then it won't break. But if it exceeds them, it will break. So you actually have this main object, which is here. This is the one which you will export. This is the name of the object. And you have the render geometry. In this case, it's 5 pieces. You have them linked to the main node so that they will be exported as one object. And then you place these 4 helpers between these pieces. So they connect these 2 pieces and you add the forces there. So when you jump to the editor, you actually can press Ctrl F4 and you automatically get the camera here. And if you go in our Petra helpers mode, you see some proxies. And then you type in to the console P debug and you press tab and tab again, P debug joins and 1. Then you see these informations here in your mesh. And you can actually now see these 5 parts which are in this mesh, like with kilograms assigned to it. And you can also see these little like squares. These little squares here, these are the helpers and the connection points between these parts. So they will actually keep these 5 pieces together. So it's 4 helpers for 5 pieces, each other attaching them together, so to say. So if you press play in this case, it will actually fall down and it will show you some numbers. And these numbers are actually the forces which got applied to it while it was like hitting the ground. If you now just press this button here, this is the hand so that you can like drag something around in the editor. If you press this and drag it slightly up and down again, you can actually see that these numbers change when you do it more drastically. Now there is a 10,000 from 300,000, so this value didn't exceed. But if these numbers for this like connection get higher, when I take like a swing, yeah, now it broke. And now you can see that this one connection here, the red number, this actually broke. So this is 340,000 from 150,000. So this limit actually, here you can actually see what happened, like shift got applied to it, like a shift force exceeded. So the dummy got destroyed and the single pieces are flying around. So this is actually what happened. And you can define these values in your 3ds Max scene. So these 4 helpers which are holding the 5 pieces together are these 4 things which are linked to your main scene. And these 4 pieces, all of them have, if you right-click them in the object properties, these limits defined. You also have defined for these 5 pieces, if you right-click them in object properties and go to user defined, you have a mass defined. For example, for this one, it's 50 kilograms. It's always in kilograms in our engine. Or you use density, then it defines the weight by volume. So for this it's 50 and this it's mass 30. If you swap back to the engine, you can actually see there is a 50 and there is a 30. So it's these 2 parts which have these kilograms. And together it's like, is it showing me the weight together? Yeah, together it's 190 kilograms. So this actually works like physically correct. So you have correct values which you define in your max scene and you can link them together with these pieces. You can do as much pieces as you want. And this is quite nice. So this will actually interact with weapons. If you have weapons in game, you shoot at them, there will be a force applied to the object, and then this force gets translated into this limits again. Or you walk against to them. You can also try this by going into the editor and press Ctrl G, and you push them around. There should be some numbers as well. Like these change actually. You can see it very closely. But they are very small, these numbers. But if I would walk, like for instance, like with 100 kilometers per hour or whatever, the stone would probably break as well. So it's not only affected by single impulses, it is also affected by speeds in the actual engine, which is actually quite good. Yeah, it's quite nice system.
We made Crysis 1 mostly with this system, so we had little wooden shacks and we could punch out walls and roofs, and we even had a section where you can go with a helicopter and destroy a village which was built out of this system. So that was one of the sections in the game that was not that good in frame rate. So entire village made with this jointed system and then starting to throw grenades in it, then it starts to go down a bit. But again, here also counts if you have a primitive physics around instead of a custom geometry, it's way cheaper for the engine to handle. So it also gets complicated if you have very large structures. Basically, these joints are, you can see it as nails. So you have 2 planks and you put a nail and this nail holds the planks together. But we recognize that if we have a lot of these joints and nails and you start to punch here, sometimes it happens that a plank over there falls down. So the simpler, the more safe it works. But you can do quite complex stuff with it. Yeah.
I mean, if it gets bigger or even very big, you can even then just splitting it up in the engine and compose it out of multiple breakable objects instead of one really big breakable object. So this works as well. You can actually create entities within the engine as well. So you have also sort of breakability setups if you do it purely in the engine. This goes as well. You have constraints, can connect object with constraints and use these constraints and make them breakable as well. You can even go more into detail. We have it in our detailed documentation. Instead of just using limits, you could even use hinges, physical constraints, where you can make physical doors, and this gets even more complicated than this. But this works as well, and you can do it in the editor, but you can also do it in the 3ds Max, in the engine or in 3ds Max. Yeah. This actually takes also like this concrete surface type into account. So when your material like takes concrete space, these pieces will actually react with concrete. So if they slide on the ground, the friction forces for concrete will be taken into account, but not like, for example, like for rubber or something which would bounce around or something. So it would actually behave differently when you have a different surface type for these properties defined. For our test object, we just have like concrete now.
From our environment art perspective, we always have the easy part because whatever we do is mostly static. We just build static worlds. On the other hand, it always comes back to us since we fill most part of the world. If there's a graphic limit and we have bad frame rates, they normally end up first to us and say, hey, you filled the entire world with stuff, so please optimize your assets. It's all easy, it's all static. We don't have characters or weapons or nearly no dynamic objects. We're very easy, but we fill so much space that we always got asked first if we can optimize some stuff. Yeah, but that's our day-to-day stuff. CGF, geometry, texture, material, proxy, LOD.
A quick workflow in this case, because this piece is already quite complicated. What we did here is we actually always took the render geometry, which is like the rock itself in this case, and we always just duplicated the render geometry if we delete this. And I always took this one, copied it over, and made a more low poly version out of it with the tools you have in 3ds Max, for example with the multi-res, and you make it with less polygons or even less polygons, and then use these meshes, for example, as proxy or as LOD or how you need it actually. It's called multi-res. This is quite useful in 3ds Max, so you can create lower polygon meshes for stuff. Some people like use the Pro Optimizer. You can use this one as well. It's quite useful too. You have like calculation and it removes polygons for you and you can add them. And this way actually we've created the collision proxies and the LODs for the meshes, so that you don't end up like in a huge pile of work and doing everything again and again. It's like doing these parts once and then just copying them over and using these quick modifiers to actually decimate them in an easy fashion. There's certain debug draw modes for our engine. It has multiple ones. You can type in debug draw 1 and there it shows you some information. You probably have to turn off the other one, this one, turn it off. In the debug draw 1, it actually shows me the different parts of this object. For example, here it's rock 1 part 1, rock 1 part 2 and 4. And it shows me how many LODs it even has.
And which LOD is currently loaded.
Yeah, it has 3 LODs and now it's LOD 0 from 3. If I go back now, you see it swaps to LOD 1 and it swaps to LOD 2 and even LOD 3.
And there are continuous numbers. It goes to 6 or something, and then it's a bit more isolated. One debug draw shows you only LODs, the other one only triangles. And we use this a lot at the end of a project when we have to optimize and we want to find out if there is a LOD in the distance with 5,000 triangles that we don't need. So we would see with a triangle debug draw, which is 2 or 3, I cannot recall. Then you can see easily, oh, there's an expensive thing in the distance and we have to find out. Or you can see if there's...
2 is now green. And you can see the poly count probably. I think it's the poly counts. Green means actually it's good.
I think if you zoom out, you have a little agenda at the lower screen edge.
Yeah, this is the poly count. 4 is texture memory. This is texture memory. So it's using 1 in the same texture, so it's the same texture memory for the same. If you need something like this, 5 is material IDs. So this is just using 1 material ID per piece. So it's 1 draw call, 1 draw call, 1 draw call. Debug draw 6 is color. This is probably diffuse color, and so on. There's like dozens of them debug draws.
Always good at the end when you realize there's no performance. We're lacking frames. Where is it coming from?
Yeah, mostly we use the debug draw, pdraw helpers, and for artists this is the easiest thing. There's dozens of shader debug modes too, but it's mostly for coders. It's this quick export function, just pressing the button from 3ds Max, and it actually works. And in other cases we can actually use the asset browser here as well. Like you have this big tool with the folders and you can import as well FBX, and you achieve the same with this as well.
You can also drag and drop. You can go from Windows Explorer and just drag and drop right into the asset browser. And it will start the import process automatically as well.
It does the same, but the only issue with that is that it's like you always have to do the same process again and import it, and it works too. Yeah, hopefully it was quite useful course.